In this presentation, we will be talking about the control of pistol recoil. First, we will explain the basic components and operation of a handgun. Then, we will model the gun as a mechanical system under passive control in order to look at the inputs, forces, and moments present in the system. Lastly, judgments will be made about recoil versus various system specifications such as bullet grain and caliber. Three important definitions to be aware of throughout this presentation are as follows. Recoil is an abrupt backwards movement from a gun upon being fired. Grain is a measurement of mass and is often used to refer to the mass of the bullet being fired. Caliber refers to the diameter of the gun's barrel. In turn, this refers to the diameter of the round being fired, and round is a synonym for bullet. Now let's talk about recoil. First and foremost, all firearms have recoil, whether it be a pistol, rifle, or shotgun. The only difference is the magnitude amongst these. Three of the main factors that determine the magnitude of the recoil are 1. The grain of the bullet. Heavier bullets generally induce a larger force. 2. The weight of the gun. Heavier guns will have higher moments of inertia, which lower the effects of recoil. 3 is the operator's level of training. A beginner shooter will have much less control of a firearm than one who's seasoned. Now, let's look at the basic components and function of handguns. The handgun we will be using in this analysis is a Smith & Wesson M&P M2.0 with 9mm 124 grain ammunition. The major components for operation are listed here. The magazine, which holds the ammunition, is housed inside the grip of the receiver. The barrel and recoil spring rest underneath the slide. After the trigger is pulled, the force of the bullet being fired pushes the slide backwards. The slide compresses the recoil spring during this movement. The spring has a certain stiffness which determines how quickly the slide moves. Because the bullet force is offset from the hand that's holding the grip, a moment is induced about the hand. This is known as recoil and will be the main study of our analysis. As with all mechanical systems, some assumptions need to be made. First, we assume the entire gun is a rigid body. This will make it simpler to analyze the external forces acting on the gun. Second, the hands will act as a rotational spring and damper assembly. The constants of these should determine the magnitude of recoil. We will assume the spring and damper coefficients to be 4,500 newtons per meter and 20 newtons per meter second. The analysis will show if these are reasonable values. Next, the type of ammunition we're using has a force of around 480 newtons. There is also assumed to be no frictional losses. We're also assuming that the angle of the hand returns to the equilibrium position, which is 0 degrees, after firing, and that this displacement angle is with respect to the vertical axis. We will also assume fixed x and y displacements so to only analyze rotation. Given these assumptions, we create this model. The spring and damper coefficients of the hand are modeled as KH and BH, and the bullet force is FB. The dimensions and total mass of the gun were also taken to calculate the moment of inertia. The free body and kinetic diagrams of the system are shown here. Note that the axis of rotation is fixed. The sum of forces in the x and y directions are not important for this analysis, so they are not taken. The gun has a total mass of m and inertia of j. The spring and damper forces are functions of the recoil angle theta. The positive moment direction is defined counterclockwise. Since the system only has one input and one output, only one equation is needed. We take the sum of moments with respect to the fixed rotation axis. The equation is then changed into the frequency domain by taking the Laplace transform and is rearranged into proper transfer function form in terms of theta over bullet force. Note that the system is second order. We can now input this transfer function into MATLAB and plot the response. Assuming that the start time is t equals 0 seconds, we plot the response here. The graph shows time versus recoil angle. We define the peak time as the time it takes to reach the maximum recoil angle. This time is 21.3 milliseconds, and the angle that corresponds to it is 22.48 degrees. The recovery time, defined as the time to reach equilibrium position again, is 220 milliseconds, or about a quarter of a second. Now we examine the video from earlier to determine if our calculations are reasonable or not. Using video tracking software, we determined the same data points as before: a start time, a peak time, recovery time, and max angle. From this analysis, we found the peak time to be 37.5 milliseconds, recovery time to be 375 milliseconds, and the max angle being 20.5 degrees. The results of the experiment. Peak times and recovery times showed the highest percent errors of 43.2 and 41.3%. The maximum recoil angles were the most similar to each other at only around 10% error. For the sake of curiosity, we decided to compare this system to a change of input. Research showed that a .357 Magnum caliber Colt Python has a bullet force of around 790 newtons. Repeating the process with this gun yielded a max recoil angle of 34 degrees, which was 33.9% higher than the Smith & Wesson that we modeled. Conclusions. The type of ammunition in the theory and experiment that we used was 9mm and 124 grain. The other type used in the theory was .357 Magnum and 158 grain. A general conclusion that we can find is the higher the weight of the bullet, the more the recoil. The opposite is also true. Since recoil is also largely dependent on the training of the operator, the spring and damper coefficients used in this analysis can differ. The experiment showed a lower recoil angle, likely due to a more experienced operator than the one modeled in the MATLAB code. The error in the time values that we found were likely due to the assumptions made for simplification. Some general recommendations that can be made for shooting are: 1. Become familiar and comfortable with the firearm. Ensure that you have a firm grip. 2. Be sure to know what type of ammunition you're using. Similar caliber bullets can have different weights. 3. These two factors and simply inexperience in general are the main cause of injuries with firearms. Thank you for watching.